Okay, a type of radiation has this wavelength. Well, I want to know what its frequency is. I want to know what how much energy it has. So I need two answers. Can you tell me the two units? What are the units for frequency that I need? 1/2 seconds. So 1/2 seconds for frequency, and then what about wavelength? Sorry, what about energy? Joules. Okay, so I need those two things. Those guys are my. And what two pieces of information do we need to know for these kinds of problems? So 3 times 10 to the 8th meters per second. And then the other piece? No. Oh, well, I'm definitely going to need that for this particular problem. But for all of these types of problems, I'm going to need to know a speed of light, and I'm going to need to know what else? Yeah, that's 6.626 times 10 to the negative 34th joules times seconds. So I don't care that you guys have these things memorized. It's not important. They'll definitely be on the exam. Just know how to use them. So both of them have units, and I'm given wavelength in meters. So how do you want to calculate the first one, given the three numbers and units we've got? Say again? I didn't hear you.
I'm trying to remember. It's length divided by wavelength.
Forget about that. What unit are we looking for?
Per second.
I want per second, right? Do any of those three have a seconds in it? And the joules, they both do, right? It's 3 to light and the joules. But I need the seconds to be in the denominator, right? So I'm going to go ahead and write 3 times 10 to the 8th meters per second. I've already got the seconds right where I want them. So now all I need to do is get rid of that meter value, and I've got 5.5. Really? You're just going to stop just like that? Really? 5.5 times 10 to the minus 7th meters. So now my meter is going to cancel out. The only unit I have left is 1/seconds. So I've got 3e8 divided by 5.5 e negative 7. And so I get 2 sig figs. I get 5.5 times 10 to the 14th. Okay. So the next one I want joules is my answer. So I'm just going to go ahead and start with the only thing that has joules, which is this 6.626 times 10 to the negative 34th joules times seconds. And I'm going to get rid of that seconds. I'm going to get rid of that seconds by doing 3 times 10 to the 8th meters per second. And that'll get rid of the seconds, and then I'm going to put my 5.5 times 10 to the minus 7th meters down here and cancel out my meter. All right, and so then I get 3.6 times 10 to the negative 19th each 19th joules. Are we okay with that? Anybody want to ask me anything about how I did that? Nobody? Nobody wants to ask me why I didn't use the answer that I got in the first part to do the second part? Nope. Nobody wants that?
Why didn't you?
Okay. The reason I didn't is because if you can calculate the answer to a problem given the information from the problem, do it that way. The reason is part of the architecture of a multiple choice exam is to trick you. Why is that okay? because it gave you the answer. So they need to make sure you know that you're picking the correct answer. So in a problem like this that has multiple questions, I guarantee you that that first answer, or one of the first answers, will be an answer that is equal to the first calculation you got, and then equal to the second calculation if you used the first answer that you generated. Do you see what we did with that first problem? I said 2 sig figs, right? So the answer is actually 5.45 and a bunch of other numbers. If you don't carry that through, you're going to get a slightly different answer. That 3.6 could be 3.5. So number one will, or A will be 5.5 times 10 to the 14th, and B will be 3.5 times 10 to the negative 19th. And D will be what we have. And it's okay to do that on a multiple choice test because they gave you the answer. So you need to be really specific about what's the answer. So I'm just trying to help you out with test taking technique. And one of the techniques is they generate answers based off of given information. If you need to calculate an answer based off of something you calculated and that's the only way you can get it, fine. But in this case, you could calculate both answers based off of constants that they'd provide you or expect you to know and the given information in the problem. Does that make sense? Is everybody okay with that? I mean, you shouldn't be okay with the trickery, but can't really do much about a multiple choice test. Okay, so we're going to do the same thing with this one, except this time we know the frequency, so we're going to calculate the wavelength and the energy. So I need wavelength, so I'm just going to go ahead and start with 3 times 10 to the 8th meters per second. That way I've got my meter unit in the numerator. And then I'm going to divide by 4.5 times 10 to the 14th, 1 divided by seconds. The seconds is always in the denominator of the value. It's per. Are we okay with that? I've got that upside down like that. What would happen to it if I had written it 4.5 times 10 to the 14th and put that in the numerator? Yeah, the denominator would be, it'd be second squared down there, and that's acceleration, not wavelength, or not length. Okay, so then the 2 seconds units cancel out. I'm gonna get 3E8 divided by 4.5E14. And so I get 6.7 times 10 to the negative 7th. And then now we're going to calculate the energy. I'm going to do that by 6.6226 times 10 to the negative 34 joules times seconds. And then I'm going to go ahead and multiply by what was given, 4.5 times 10 to the 14th, not negative 14th, 14th seconds. Seconds cancels. I get 6.626 e negative 34. So I get 3.0 times 10 to the negative 19th joules. Identify where this is going to be found on the spectrum. Okay, so where is this going to be found on the spectrum? We had a wavelength. Oops, I'm supposed to put meters here. So how can I, what would happen to this thing right here if I turn that thing into 10 to the minus 9th? What happens if I turn 6.7 times 10 to the minus 7th into into 10 to the minus 8th? What happens to the decimal place? Which direction does it go? No. Woohoo! Think about that for a second. When you make it 67 instead of 6.7, but the exponent is 10 to the minus 8th, what would you do to turn that into scientific notation? You'd multiply 67 by times 10 to the minus 8th, and you'd get 6.7 times 10 to the minus 7th. Does that make sense? If this number here turns into 67, that's 10 times bigger, right? So this number needs to be 10 times smaller, and that's 10 to the minus 8th. So this number and 67 times 10 to the minus 8th meters, they're the exact same number, right? What if I go 10 to the minus ninth? What is it? 670. Okay. I did that for a reason. It's not all arbitrary. Where'd it go? And the reason I did that is because that. So 10 to the minus ninth is nanometers, and visible light is usually listed in nanometers. So 400 to 750 nanometers. So we got 670. So what kind of light is this? It's definitely visible, right? And I'll go with, you okay with orange? How about like blood orange, orange? It's kind of color look like to me. All right. Spectra. How do you want to explain atomic line spectra? There's a few different answers you could, at least two drawings you could give. So what do you want to give? What did you guys draw? Did you draw the atom or did you draw the energy level diagram? Atom? Okay. So I got a nucleus, and then I got these orbitals going around the outside here. And so I got an electron in here, and it receives some energy, and it hops up to, say, here. And then when it falls back down, as it's falling back down, it gives off light. And each one of those lights is going to be on some spectrum, either visible or ultraviolet. The other way you could do it is if you had an energy level diagram. You could say you've got some electrons here, and this electron, I don't know, gets bumped up to here, and then when it falls back down where it's supposed to be, it gives off light, and that light is like one of those guys there. Either of those is totally fine. Do both of those make sense? I give it energy, it jumps up, and then when it falls back down, it's got to give me exactly the same amount of energy. It might not give it to me all at once. You give somebody a $100 bill, they might give you a 50, two 20s, and a 10, but it's still $100. And that's really what's going on here. I get all the energy I put into it back, it's just, it might not come back to me right away. So this is what happens when you've got glow-in-the-dark paint. So you shove energy into those molecules and atoms, and they give all of that energy back. It's just that they give it back a little bit slower than they got it. Any questions about that? Should probably actually change these to different colors. Like do. No, not that one. Really? Why does it always do that? I should know that by now. We could do what, blue? Maybe like a, oh, I want like a yellow. Something like that. Artistry at its best. Yeah. Me and Bob Ross, right up there. Yeah. Happy clouds, yeah. Happy trees. Yeah. I heard that there's some website out there that just does Bob Ross 24/7. Like you just flip it on and it's just constantly on. So you're feeling upset, you just put that on and it'll just drone you to sleep. Happy sleep. You should think about that next time Frankie's freaking out. You just can't be upset when that guy talks. It's just like,
It drives me nuts.
he drives you nuts? Really?
I didn't like it when I was a kid.
Okay.
Quickest way to turn the TV off.
What evidence leads us to be that light is both a wave and a particle? Okay, so how about a wave? What do we know about things that make it act like a wave? Overlap? What do we call that? In football, it's pass interference. PI. I should always just erase and start over. That's something weird about the brain. So we have constructive. And we have destructive. And we see this in the bands of light and the bands of dark. So this was that flashlight, 2 slits over the flashlight, and you point it at a wall and you get light, dark, light, dark, light, dark bands. Like somebody was holding, I don't know, it was like shining through a fence or something like that. What's the other part? Interference, and what's the other thing? Refraction. And we see refraction in like a oasis effect. You see it with like the swirl. And that broken pencil effect. Okay, and particle. What was that thing called? Okay, so thing Einstein won his Nobel Prize for. Photoelectric effect. So, so the wave behaves like a quanta or a photon, a little packet of energy that you can't sum together, individual packets of energy. And this is how solar panels work and the like. Also how this atomic line spectra functions. And going along with the atomic line spectra, what else goes along with that? Okay. Anything else? Any more questions on this? Good to go?